On chapter 3, we started the study of dynamics, we left kinematics, and we started the study of the reason why objects move the way they do. But everything that we've covered in chapter 3 regarded only motion in one direction, only in one dimension. Everything that we're going to start talking from now onwards is going to regard motion in 2 dimensions. You don't have to worry about motion in 3 dimensions. Mechanics 1 syllabus does not cover that part, but you will need to know how to operate with questions and problems regarding the motion in 2 directions. That's the reason why I started with this lesson 0. This is not part of the mechanical syllabus per se, but it's something that you need to know in order to understand how to solve these questions. And everything over here regards what the things that you already learned is the very basics of dealing with vectors, how to add them, how to decompose them, etc. In terms of math, the core math, everything that you need to know in terms of trigonometry, to be more specific, is the Pythagoras theorem and SOHCAHTOA. Okay, so let's look at a random vector. For example, this vector v over here in blue. Okay, what do I mean by decomposition of vectors? If you have a vector that has a random direction such as this one, it's always important, interesting, it's always a tool if you would know how to break it down into its components. Components in an arbitrary axis, which is, for all situations here in mechanics, a system of axes that is perpendicular to each other. Most of the times, the y-axis is going to be vertical and the x-axis is going to be horizontal, with some very high-profile exceptions that I'm going to mention later on. But the axis is always, these 2 axes are always perpendicular. You have the y-axis and you have the x-axis. Decomposing a vector means breaking the vector down with whichever direction it may have into components that can be projected in the y-axis and in the x-axis. That's what I did over here. You have this vector v, right, in blue, and the idea is that you break it down into a vertical component represented here in purple, that's vy, and a horizontal component represented here in orange, the vx. What are the parameters that you need to know? It depends on how you deal with this. The vx and the vy could be parameters by which you could get all of these 2, or these 2, the magnitude of the vector represented by v, and this angle that it makes with the horizontal axis, theta, could be the 2 parameters by which you could get the vy and vx. Let's see how this is done. But before that, I want you to pay attention to the fact that these 2 diagrams, they represent virtually the same thing. Okay? In both of them, you have a horizontal component, which in this case is exactly the same. Okay? This is just copy-paste of this part. And the y component, in this case, is represented on this referential over here, x, y. But if you would pick this part up and shift it over here, this is what you'd get. Okay? The advantage of representing the components in this form is that here you can see more clearly a rectangle triangle. But I will be using this one more often because this allows me to represent all vectors always in the same point. And all situations regarding mechanics, they regard an object that can be thought of as a point mass. And this is the point where all the forces, now that we're talking about this, the specifics of this chapter, this regards forces, which are vectors, they are going to be applied on this point mass. So this basically explains the advantage of representing vectors using this diagram instead of that one. Okay? But they are virtually the same. So if you have any 2 of these, don't forget that this is v, right? V is going to be the hypotenuse of this rectangle triangle, and each one of the components, the Vx and the Vy, are going to be the sides of the rectangle triangle. So using Pythagoras theorem, you know that v squared equals Vx squared plus Vy squared. So if you know any two of these, you can get the third one. All right? And you don't need to know the angle to know that only. But if you do know the angle and one of these, you can get the other two as well. And you use what for that? You use SOHCAHTOA. All right? SOHCAHTOA is just a mnemonic that you use to know how to operate with these trigonometric ratios. You know that the sine of an angle in a rectangle triangle is the opposite side over the hypotenuse. So in this context, it's Vy over V. The cosine of this angle is the adjacent side of the rectangle triangle over the hypotenuse. So it is Vx over V. And the tangent of this angle equals the opposite side over the adjacent. So it's Vy over Vx. Just rearranging this formula, you know that Vy is going to be V sine of theta, Vx is going to be V cosine of theta, and the theta itself is going to be the tan negative 1 of Vy over Vx, right? So if you know the angle and the hypotenuse, you can get this one. With this one, you can get everything else that you know about the triangle, right? In any rectangle triangle, if you know two parameters, whichever they are, the angle, the magnitude of the vector, each one of the sides, if you know two of them, you can know everything about it just using the Pythagoras theorem and SOHCAHTOA. All right, that's what I have over here. Now, you are going to deal with more than two vectors applied to the same object. So you need to know how to add them and how to subtract them. Okay, and this is very simple. You already knew this for vectors in one dimension, so I'm going to use these markers. If you have two vectors pointing in the same direction and you want to add them, what do? In front of one, put the other, right? Heads go with tails, so at the tip of one vector, you put the other. If you want to subtract them, you say this minus this one. At the end of the first one, just reverse the position of the other, and it's going to be the same logic, if you will, okay? At the tip of one, now put the other, but reversed. What is subtracting? Is adding an angle, a vector that is itself multiplied by minus 1. What does multiplying a vector by minus 1 do? It reverses its direction, all right? This is what you already knew in one dimension. In two dimensions, it's exactly the same thing. But now you will have angles, so you have to use these things in order to calculate the magnitudes. But this is the main idea. Let's look at this. You have now a vector v and a u, okay? You are adding them. So the principle is the same. At the tip of the first one, add the second one. That's what I did over here, all right? And what is going to be the outcome? It's going to be a vector that starts at the beginning of the first one and ends at the end of the last. Since you only have two vectors in this example, it starts at the beginning of the first one and ends at the end of the second one, okay? So the problem now is going to be, what's going to be the magnitude of this and its direction? The idea is that you use the components of each one individually to get that. And pay attention to this. I'm going to zoom in to see if you can see it better, all right? I decompose vector v into its components. Vx, Vy. I decompose vector u into its components as well. Ux, Ui. Okay? What is this? Seems complicated, right? But if you put it like this, it's not, right? This is the outcome, the resulting vector, v plus u. This is going to be the horizontal component of this resultant vector, and this is going to be the vertical component of the resultant vector. And how big is this? This is just the outcome of adding its horizontal component, see? Vx plus ux. Same thing for the vertical component, Vy plus ui is this, right? As simple as that. In terms of using the math to calculate the values, v plus u, I'm going to decompose and I'm going to use these brackets all the time. So get used to seeing this. Most textbooks, they don't use these brackets. This is the way I was taught. I got used to it, and by having this always in front of me, I can have at a glance everything that is going on in terms of the vectors that I have to deal with. All right, so I put on one of the lines that everything that is happening on one component, in this case x, and in this one, everything that is happening in the other component, y, okay? So u plus v, or v plus u, general, is on the x component, vx plus ux, on the y component, vy plus ui. That's what I showed you a little while ago. Now, how do you add them? What is vx? Vx equals v cosine of the angle, and vy equals v sine of the other angle. The first angle is theta, the second angle for you is alpha. So, where am I? I'm here. The vx is v cosine of theta, and the ux is u cosine of alpha. For the vector v, vy is v sine of theta. Where is it? Is v sine of theta. Is this one over there? And uy is u sine of alpha, right? So if I know v and if I know the angles, this is going to be a number. Make sense? If you know what this angle is, and if you know the magnitude of both b, v, and u, all of these are going to be numbers that you can plug in your calculator or just do it by head. And this is going to be a number, this is going to be a number. What is this number? This number is the magnitude of the horizontal component of these two angles put together. This number is going to be the vertical component of these two vectors added together. Pretty simple. What if you are subtracting vectors? As I told you a little while ago, subtracting a vector means adding the vector that you are subtracting by the negative of it. Okay, so again, I have the v and the u, basically the same, but now instead of a plus, I have a minus. So what am I doing? I'm just reversing the position of this one. I'm basically adding by this times minus 1. And multiplying a vector by minus 1 just flips it around. See? Originally, it was pointing that way. Now it's pointing this way. Now the outcome vector is going to start again at the beginning of the first and at the end of the second. Now it's going to be this one over here. But the principle is the same. See? How big is the horizontal component? It's going to be Vx minus Ux. What is going to be the dimensions of the vertical component of the resultant vector? It's going to be Vy minus Ui. Right? And everything that I said over there is still valid over here. Just one quick note for you to know that this is true for all algebra. If you are adding vectors, numbers, whatever, doesn't matter the order by which you're adding. V plus u is the same as u plus v. But if you are subtracting, the order matters. V minus u is different from u minus v. Okay? So this is just a quick reminder of the things that you need to know. Again, Pythagoras theorem, SOHCAHTOA, knowing how to decompose vectors, and everything is going to be simple if you are comfortable with dealing with these things. If you are not, I advise you to solve any questions from previous years regarding SOHCAHTOA and Pythagoras theorem, because everything or most of the things from now on in mechanics, they are going to deal with this.